Okay, see Lindelof videos writing linear equations in standard form, and we're going to talk really briefly about what that means to us. First, I wanted to just say this about that, which is that there are three forms of linear equations that you're going to see. And the first one is the slope-intercept form. And slope-intercept form looks like this. And when you have a professor or a teacher that asks you to write an equation of a line, unless they say otherwise, this is the form that they generally want. It shouldn't matter which form you use, but this is the one they're generally interested in. Point slope form is the second one, and point slope form is the one that you're going to see most often in pre-calculus, calc 1, 2, 3, etc. because this is the way you kind of set up something called the secant problem or the tangent line to a function problem. So this is something that you're going to need to work on. However, this is the one we're talking about today. And the standard form is capital AX plus BY equals C. And the reason that we have capital letters is, in my opinion, to tell you that this A right here, so this one up here, sometimes instead of MX, it's written as AX, and that's slope. And one of the reasons that we use this capital A is to tell you this is not necessarily equal to the slope, right? A simplified slope. Okay, so let's move on. So what you're going to be asked to do is this. You're going to see this equation right similar to this, and your professor or your teacher is going to say, convert this to standard form. So when we think about standard form, and this frankly is the point in the video where you stop and you copy these notes, capture it as a picture, however you're going to do it, capture these notes because this makes it super easy. In standard form, this A right here, right? This A right here, this A is this A and B, this B is this B. So A can't be a negative number. This is actually easy to fix, but you're going to see it, and it's kind of a trick, easy to fix. A and B can't both be 0. A, B, and C are integers, right? And there can be no greatest common factor, and we'll kind of talk about what that means. All right, so let's just actually do this. So we're going to move to this form. So I'm going to take this equation. I'm going to move, here's the A value, it looks kind of like the A value here. I'm going to move 4x, I'm just moving it over, plus y would be equal to negative 1, right? Negative 4x plus y would be equal to negative 1. So we look at this, and hopefully you can see the problem already. And the problem here is that A can't be negative, and in this case A is negative. So this is a really easy fix. All we're going to do is multiply the whole thing by a negative 1. So I'm going to multiply negative 1 here, I'm going to multiply it here, and I'm going to multiply it here. It's the way we would do it in regular algebra. This just makes it quicker. And negative 1 times negative 4 is 4x. Negative 1 times y is negative y. And obviously, negative 1 times negative 1 is 1. And I think we can see that we have this all fixed now, right? This all kind of worked out. So this is our simplified answer. Keeping in mind that A, the trick on this one was that A can't be negative, right? Let's do one more really quickly. So this one is a kind of, this one's a little bit crappy looking, but we can fix this easily. This is really easily. So we're going to do the same bit of algebra first. We're going to move this. We have to subtract this 3 halves x. So I'm going to do 3 halves x. I start off by just starting to look at this form right here. So the x factor has to be first, so I moved it first. And then this is a positive y, so positive y here, right? Is equal to c, and the value of c in this case is 8. However, hopefully you can see the issue here, the problem here. Let me rewrite this really quickly. The problem here is really simple. We had negative 3 halves x plus y is equal to 8. And I move this over so we could do this. We have two issues here. One, a can't be negative. Two, a, b, and c are integers, and 3 halves is not an integer. Really, really easy fix. I'm going to multiply the whole thing by the denominator here. So I'm going to multiply it by a negative because it has to be negative, right? So I'm going to multiply negative 2 because of this, negative 2, times all of this junk over here. So 3 halves x plus y equals 8. So far, so good. And then look what happens when we multiply this through. I'm going to multiply it here, here, and then lastly here. And we're going to get negative 2. Oh, this was a negative 3 halves x, right? Sorry. When I multiply this through, negative times negative is a positive. 2 times 3 is 6 over 2x. You can already see it happening, can't you? Negative 2 times y is negative 2y. And negative 2 times 8 is equal to negative 16. So far, so good, I hope. And here the answer is this, right? This, see how this is going to turn into an integer. This is 6 divided by 2 when you have a fraction, right? It's top. So if I have 6 divided by 2, it is exactly the same as 6 divided by 2. So a fraction turns into that. So 6 divided by 2 is 3 minus 2x is equal to negative 16. So hopefully this makes some sense. This is not a difficult thing. You just have to know the rules. And we can look here. It says that A can't be negative. It doesn't say that B can't be negative. It says A can't be negative, and this is not negative. This is positive, right? The rest of them are integers. Negative 2 is an integer, and negative 16 is an integer. And they don't have, so this is the thing that throws people off, no greatest common factor, right? So 2 and 16 have a shared factor, but it doesn't share it with 3, right? So they have no shared factor between the three terms. And so here's our answer, right? So just back to it really quickly. If I could tell you anything in this video at all, it would be to know these rules. Copy them down, put them in your phone, do whatever you have to do, because if you know what this is, then you can change everything to fit the rules, okay? Hey, thanks for watching. If you have questions or comments, as always, let me know. And if you haven't already subscribed, please